Okay. So we'll start. All right, we'll start here. Okay, so we see a man standing on a hill, and he is looking forward initially, and that forward line is labeled horizontal, but there is another name for it that you'll find in the textbook, which is the line of sight. As you can see, when he looks above the line of sight or the horizontal, he forms an angle when he looks up at the plane. And that angle is called the angle of elevation. And when he looks down at his dog, he forms an angle of depression. All right, so those are some things to bear in mind. Any questions so far? Okay, let's look at, let me just make sure I admit somebody. So let's look at another image. And I want you to memorize the measurements in this image. It says fill in the blank, all right? The blank is this portion here. It says the distance between two buildings is 40 meters. The top of the building CD, so this building is labeled CD, has an angle of elevation of 30 degrees, measured from the top of the building AB. So someone is up here looking up at another building, looking at the top of another building. If the height of building AB is 30 meters, and the bases of the two buildings are on the same horizontal plane, then the height of CD to the nearest meter is. So we have to go to the nearest meter. Notice all of these measurements are to the nearest meter. In reality, you'll never get something that's exactly 40 meters apart. There'll always be that point 0.034 something, but all of these measurements are rounded off. So that's what our final answer will be. It'll be an answer, a number that is rounded to the nearest meter. Okay, we'll stop sharing. I hope you memorize the details of that image because we're now going to work out the problem. All right, so we have, any questions so far? All right, so far, okay. All right, so we're going to draw our important portion of the diagram, that triangle that we saw formed by the two buildings. But let me just bring this down. Yes. I would do it freehand, but it's not always, it doesn't always work out for me when I draw freehand with this program. Okay, and even without the freehand, still not going to be perfect. Okay, and then if they're on a horizontal, so just put it there. All right, so we have, let's write in the specifics. So this is the tower AB, the building AB, and this is our CD tower or building. What's the height of AB?
30
30, yes, 30 meters.
centimeters.
Okay, so 30 meters. A meter, I want you to think of, I think I've mentioned this to you before, is from the floor to the doorknob. So 30 of those, 30 meters. 2 meters would be like 6 feet, just to give you an idea. All right, so here we have a height that we don't know about yet. So we don't know this height. This is like totally unknown right now, but we want to find it. And let's see if we do have the skills to find it. What's the distance between the buildings?
40.
40 meters, very good. Okay. And the angle? Anybody remember? Ah, come on, guys. It's 30 degrees. Okay. Now, a property that you need to know is that when you have a rectangle, which is the situation I see happening here, the lengths correspond as well as the width, right? And that's because the lengths are parallel as well as the widths. They're both parallel and they're at 90-degree angles, right? So we can know that the length will be the same. For the lengths will be the same and the widths will be the same because of this property, these properties that are involved in forming a rectangle. So can you guys tell me what is the length from this point to this point? What is the length? Is that something we can know? Or is that just something that's unknown? Anybody? Can we know the length? Okay, so it's 30. And your justification, how can you justify saying that it's 30? Like, how can you say that? Can anybody help out? Why is 30 is correct, but why?
Because it's the same height as the building.
Okay, it's the same height and we've made a rectangle, right? And the properties of a rectangle are that the sides are equal. All right? The at least two sides are equal, right? Not the whole thing, because then it would become a square. So we do have a reason for this being 30, and that also has an effect on our knowledge of the height. Now we know that the height cannot be less than 30 meters. So we know something. We know that there is an unknown portion of the height that we just don't know about, that we need to find, right? But there is also something that we do know, which is this 30 meters. So if we solve this formula right here, x plus 30 meters, then we will have our answer. But we have one issue. We need to find the x. Can anybody tell me what I should do to find x? Can I use Pythagoras? Would that work? And if it does, how? And if it can't, why? Why can't we use Pythagoras? Okay, the reason is there's two unknowns. Remember in Pythagoras, you always get two things and you always look for a third missing part. In this case, we don't know the length of the hypotenuse and we don't know this side of the right triangle. So we're missing some information here. We're missing too much information to be able to use Pythagoras. So this is no, can't use Pythagoras. But because we have an angle here, this tells me I should try to use trigonometry. And I know about I know about ka, and I know about toa. And I think we discussed these things already. And you've probably seen and used these things already. But of course, we're just refreshing, right? We don't want to assume that you know these things. So we're starting from scratch. Okay, can I use so? Anybody? Can I use sine? Erase that. Oh. What do you guys think? Can I use sine? Well, my angle in this case would be 30 equals opposite. Okay, we do have an opposite in this problem, but oh boy, uh-oh, we don't have a hypotenuse, so that's not going to work. What about cosine? So cosine of 30 equals the adjacent. Okay, we do have an adjacent, which is 40. Okay, things are looking bright. I think we got it, guys. But there's no hypotenuse. Oh boy. I think we're going to be using TOA. What do you guys think?
Yes, sir.
Yeah. All right. Because check it out. Check it out. We have tangent of 30 degrees. We have an opposite. We have our x. And we have our adjacent, which is 40. So we do have something to work with for tangent. But notice when it came to so and ka, we just were missing too much information, just like in the Pythagoras problem. Okay. Okay, so there we go.